All right, everyone. Are we good to start? Is everyone good? Is everyone pumped? Yep. This is good. Yeah, Malika. Good question. I'm going to open I'll open the drop boxes tomorrow. We're just going to finalize a couple of things with the marking rubric. So I just want to make sure everything's good and kind of transparent before we open them up. When I first arrived at Swinburne, they didn't even have rubrics for those labs. So I'm adding all those and making sure that I'm working with your tutors to make sure that everything's really consistent in regards to what you're being graded on relative to any modifications that they made during the labs themselves. So that way it's going to be fair for you guys all around. So I'll put an announcement up tomorrow when those drop boxes open up. Yeah, fantastic. All right, guys, as you know, and I'm still getting emails about this. I can't believe it. So, gang, 17th to the 23rd, I think it is, the 24th. The university's closed, right? So this is the last day before your week break. As it says in the announcements, the 17th to the 23rd of April is the break. So your break starts tomorrow. So if you have a lab on tomorrow, you don't have a lab on tomorrow. You've got your lab on the next session. Does that make sense to everybody? Because I'm still getting emails about that, and it's a little bit concerning that you don't read the announcements. We're good? Yeah, fantastic. Remember, guys, if you ever get confused, check the announcements because I put all the really important stuff up on there as well. Okay, so without further delay, I know a few of you have been, waiting up all night for this. I know every week it's almost like there's like you've been waiting all your life for these lectures, and you just probably don't sleep for a night beforehand as well. I mean, this unit by 10,004. I mean, it's probably it's definitely more popular than Taylor Swift. I'd say that. Um, I'm not sure if Taylor Swift fans are called Swifties. Get about four alarms set and didn't need a single one. That's it, Mo. That's fantastic. Um, so if Taylor Swift fans are called Swifties, what are Bio 10,004s called? Anatomies? I'm not sure. Or physiologies? All right. What I do know is I know you need to know these learning outcomes, right? So, a couple of really important ones here. Physio heads, that's pretty good. That's a good one. We might run with that for now. Um, by the end of this lecture, so you got to understand these particular outcomes. I won't I won't read every one of them out. Remember, the whole purpose of this of this lecture, is that we go through the really important parts. Again, know the very basics here of vasoconstriction and vasodilation, just contraction and relaxation. You need to know this terminology here. So I can't tell you everything that's on the exam, right? But what I can tell you is what you should know in depth. Remember, the exam format itself is going to be 60 marks come from multiple choice questions, which is similar to the ones in the quizzes, right? They're not as hard as the ones in the quizzes. I've made sure that they're actually not too tricky, but it'll be basics. It'll be things like this, like what carries blood away from the heart, that sort of stuff. What's the smallest, arterial blood vessel or so? And it will be, capillaries. Um, no, the exam isn't online, Daniela. Will there be leveling diagrams? I can't tell you. I can't tell you that. But what I can do is I can give you guys access to the last year's lectures. I mean, last year's exams. I'll put them up over the break. Okay, so and then there's going to be, so 60 of your marks will come from multiple choice questions, and then there's going to be 40 marks that come from long answer questions, and they're ones which I'd expect you to write like half a page or something at least on. And they're going to be big concepts, right? So nothing that's going to be too small, like nitty gritty or anything like that. Okay, when we talk about veins, we're talking about venules and veins. They return blood to the heart, and we'll talk more about that later on. Remember, your arteries move blood from the heart, your veins take it back. Okay, you have to know this. You have to know the three layers of your blood vessels, right? Your intima, your media, and your externa. This is it here. you can see here as you go from an elastic artery to a muscular artery to an arteriole, all the way down to a capillary, how the actual components of those layers actually change. For example, your arterioles only have a tunica media and an endothelium. They don't actually have the intima or the externa. Muscular arteries have all three, but they're a little bit different. And all it is here is as your aorta starts to actually move down and shrink in size, because it doesn't need as much pressure because it's not as close to the heart, what you'll find is that it actually gets smaller and smaller to the point where it actually branches out into a capillary. There's a point here where you can see here the oxygenated blood. I'm going to put my cursor on where the oxygenated blood is moving down the aorta through a muscular artery, down through into an arteriole, into a capillary. There's a point here where at a capillary they're really, really thin, right? And that's that point where where the blood has run out of all of its oxygen because it's been giving it to all of the other cells. And then basically it hits into the venous system, and it's going to return back up to the heart to get pumped back to the lungs and get reoxygenated, right? Okay, go through. You need to understand the basics of all the layers of this. Now, the difference between arteries and veins, I want you to know. This is really easy stuff to remember. Arteries move blood from the heart to the body. Veins take it back. Arteries are thicker and have higher blood pressure. Why would they be thicker and have higher blood pressure? Can anyone tell me? I got some great hay fever this morning. Still waiting for an answer. We're not going anywhere until I get an answer. They pump the blood out of the body, push blood. Yeah, so there's they're the ones that are receiving more pressure. Yeah, so they got more. There's higher blood pressure, and they need to have that thicker wall because of that level of pressure. Right? They're literally receiving that pump, and all the blood's being pushed out. So anyway, Manning's equation: smaller channel means more pressure. Yeah. Oh, yeah, that's right, Ethan. Yep, good stuff. Okay. So just a couple of very basic sort of points there in regards to the differences between your arteries and your veins. So when you have your from your capillary, so basically you got three different versions of your arteries, and you need to know these: your elastic arteries, your muscular arteries, and then your arterioles, right? So again, that's just from large to medium to small. But you need to know the definitions of those, okay? So your elastic arteries are going to be big ones such as your aorta, your pulmonary trunk, that sort of stuff as well. Your muscular arteries are going to be more medium-sized arteries, which makes sense as well. They're going to be the ones that are going to be branching off and getting a little bit smaller. They're not going to be in your solar plexus. They're going to be the ones that actually moving out and actually delivering blood to other areas. Your arterioles are going to be much smaller, and that's, as I mentioned here, they don't have any tunica externa, as I mentioned before, and either no media or very, very thin. Okay, this is the very basics of what I want you to know. You don't need to know everything that's on this diagram here. You need to know these, though. You definitely need to be able to identify these. These is really, really simple stuff because it's all quite, with the exception of aorta, which you should know anyway, right? From your high school studies. Everything here makes sense in terms of the way it's labeled. Your ascending aorta is here. The aortic arc is here. That's the arc, right? The arc also has these other arteries that span off it as well and go off and deliver blood to the upper parts of your body, your head, your cranium, your neck, your shoulders, and your arms. The rest of the descending aorta is running down here. Makes sense, right? It's ascending here, the arc's here, it descends here, and then it's the abdominal aorta, which comes over here and then branches out into two different areas. Does that make sense to everyone? I mean, it should be really easy for you to remember that. Yeah, fantastico. Oh man, my hay fever is awesome today. Best hay fever I've had in a while. Excuse me. So here we have our hero. This is the ascending aorta. This region right here starts on with the curve, and then it basically goes around the aortic arc. Here it runs down the descending aorta, and then it's into the abdominal aorta. And basically what ends up happening here is once it reaches down the bottom here, it branches out into the iliac artery. The reason why they call it the iliac artery is it's all around that area of where your iliac crest is in your pelvic girdle. Okay, so you've got to remember, just remember the basics of what comes off the aortic arc. This is really, really important, and it's kind of fun stuff in it anyway. The brachiocephalic trunk, the left common carotid artery, and the left subclavian artery. They're really important for those of you who go on to do other studies, which will incorporate anatomy and physiology as well at second and third year. Then you'll learn more about this. But this is a really important group of arteries which actually deliver blood to the head, neck, shoulders, and all those sorts of things. And it's also one of the reasons why some people, when they have a stroke, where they actually get, a part of their actual body, one of their arteries actually gets clogged. And that's why they usually have problems to certain parts of their body, because it depends on what actual artery that's been blocked. And because of basically what ends up happening is the delivery of oxygen doesn't occur to that particular part of the body, and so they end up having some level of abnormalities there as well. Okay, the abdominal aorta is, as you can see here as well, there's some really cool stuff that's going on here. Whole bunch of the iliac arteries, they branch out and they basically will deliver blood to the lower extremities. This is a good flow chart for you to be able to remember for the basics of what it is you're going, the arterial highway, really, if you want to think about it that way here. In terms of what delivers blood to the lower extremities, so to the trunk and lower down below, you can actually see there as well. It's pretty cool. You don't need to remember every one of these. This is really just for your own learning. You do need to know the difference between hypertension and hypotension and what normal blood pressure is. And an aneurysm, you need to know what an aneurysm is as well. This stuff is is quite common knowledge, I'd say, as well. Everyone knows what an aneurysm is. Do they really know how it's caused? Not really. Basically, an aneurysm is a bulge in an arterial wall. If this happens to your aorta, like what we've got here, then pretty much nobody survives a burst from the aorta. That's because it's the superhighway of delivery of your blood, and without it, you're in a bit of a pickle. So things to remember: your arteries carry blood away from the heart, and remember, you need to know the different three types: elastic, muscular, and arterioles. You need to know the basics of the parts of how the aorta is divided into parts, right? Ascending, arc, descending, right? And you need to know the difference between hypertension, or the link between hypertension and aneurysm and vascular conditions, right? My apologies about my runny nose right now. Give me one moment, everyone. I'm going to go get a tissue. Okay. We good? Can everyone still hear me? Yeah, fantastico. All right. Yeah, I've been. Is it maybe it's because of the wind or something like that? But has anyone else had bad hay fever or anything this late sort of burst of summer weather that we've had in autumn? I definitely have had it lately. So maybe it's just the wind or something like that, knocking about some of the pollen. Yes, it's sad to hear that, but good to know that I'm not the only one as well. Hey, you know that I wouldn't be scientists. We wouldn't be good scientists if we didn't have nerdy allergies, right? So here we go. Let's get into it. So yeah, the wind's pretty nasty for sure with allergies and stuff like that. Okay, so this time we're talking about veins, right? Let's get onto it. Veins will take blood back to the heart. Yeah, this is what I'm talking about, that interplay here. Once we get down to the capillaries, right? Once we get down to the capillaries are almost shared, right? So in this case here, you have your venule and your arteriole. They're the smallest versions of your veins or your arterioles. Your capillaries, though, are almost shared, right? And that's because you have them, essentially, the blood comes down here, it gets delivered from the arterial system. It's running out of oxygen here. It's lost its oxygen. It enters into the venal capillary bed, and then it will go end up making its way through a small venule into a normal venue, into a vein, and then it will go onwards towards the heart, where it will then be pumped from the heart to the lungs to get reoxygenated, and then it will go be delivered back to the heart, where it will enter into the actual aortic system again as well. Pretty cool stuff, huh? Now, compared to arteries, veins are going to be thinner and they've got lower blood pressure. As we mentioned, they don't actually need as much pressure. And for that reason, because they're not receiving that big pump, there's a lack of, they don't require the thicker walls like you get with the arterial system. This is a good comparison between the two. You can actually see here the differences between your arteries and veins. As you can see here, here's a typical artery, here's a typical vein, and when you compare them together, you can actually see which ones are thicker and which ones are thinner. Okay, so the structure and function of these, again, you need to sort of think about this in the similar fashion as what we were talking about with the arterial system. Large, a normal, and then the venules, right? Large vein, normal vein, and a venule, and then all the way down to capillaries, right? Makes now the naming system is obviously going to be a little bit different. That's not going to be too hard for you to be able to remember. Large veins have all three tunica. Just go back up here as well. Large veins have all three. Your normal vein has all three as well, but it's smaller. Your venules a little bit different, right? Your venules and your capillaries are different. Now, what they also have, your large veins have, is they have valves, right? These valves function very similar to the way that I'm trying to think of an analogy here that might be no analogies are coming to mind here. But basically, as blood moves up, that puts pressure on these valves. They then open up, let the blood flow that way, and behind it they close. And what that does is it prevents blood from actually being able to enter through back through a particular vein. So blood can only go one way. It can only go up the leg. It can't go back down, and it can't do that because the valve closes. Um, During that whole contraction process as well. Okay, you need to be able to think of your arterial and venous system as a circuit, right? They're basically interlinked, right? So you end up having your large arteries and your veins. They run side by side. Right? So if you think about it, um, your aorta is running down, but then your major vein actually going back to the heart is running through that middle part of your trunk as well. So they run side by side. Really, really important because they need to deliver the actual blood back. So this is it. If you compare this image to the one that we had earlier on, where it shows your arterial system, you can actually see them running side by side. Now, as I mentioned, you don't need to remember everything here as well, in terms of all of the nomenclature that you've got here. But I do want you to remember the major parts. Now, there's a whole bunch of veins which are classified as either deep veins or superficial veins. You need to know what the differences between those two are. Obviously, superficial means that it's going to be at the surface of the epithelium, closer to the surface of the epithelium. Um, a deep vein obviously means it's going to be much deeper in the actual in the muscular system itself as well. Now, if we want to think about the lower limb, so hang on, we'll just go back up here. The upper limb, there's a few really interesting ones here. You don't need to remember the names of any of these as well for the exam. You can definitely see here in regards to where the venous system is essentially delivering all that deoxygenated blood back in a very similar route as to what the arterial system delivered it in. Okay, a couple of interesting ones here as well. The veins that actually that collect blood from your foot, leg, and thigh, basically transfer that back to the heart as well. So you can see here, there's which ones are deep veins and which ones are superficial veins. The femoral vein is obviously is a deep vein. In contrast to that, the great saphenous vein is a superficial vein. You can tell that from the key over here as well. And actually, when you go back here and have a look and zoom in on this one a little bit bigger on your slides, you should be able to, it's a bit of fun actually when you go through and sort of have a think about which veins are deep and which ones are superficial. So, okay, so varicose veins. Anyone ever wondered why these actually occur? Well, does anyone know anyone who's got varicose veins? Yeah, that's right. So they're basically, they happen as you get older. As you get older, they happen just from wear and tear. Yep, wear and tear on your venous system. What it is especially areas, people who stand on their feet for long periods as well tend to develop these, and they also develop spider veins as well. If you've ever seen those, they basically look like very superficial veins. Now, these are only superficial, right? They're not on the deep veins. Basically, what ends up happening is your superficial venous system, they're quite thin. There's not a lot of pressure there as well. What ends up happening is the valves end up rupturing. When you get the valves rupturing, that means that you basically, instead of having this normal blood flow, what ends up happening here is the valve system isn't working. So blood kind of bunches up. Is it true that wearing compression socks while working can reduce the chance of this? It can help with the pressure on it. It definitely can help. Compression socks are probably better for deep vein thrombosis prevention, but it definitely can help. The issue with varicose veins, though, is they can happen anywhere down your leg. So if you're sort of thinking, yeah, so Amelia, so if you've got them, and I've got some of them as well, but and I've had them since my 20s, and the reason being is mostly because of sport. So doing a lot of sports that I sort of grew up doing and still do, there's a lot of impact on my lower extremities, and so that ends up putting a lot more pressure in terms of on the veins. So yeah, Amelia, if you've done anything where you, even if it's a job where you're standing for long periods or something like that, anything that's going to put more pressure, then you're going to end up having a greater chance of having a valvular sort of incompetence. Okay, and so that basically just means there's nothing bad about these. They're not dangerous or anything like that. Some people, especially if you're one of those Hollywood types, which I know a lot of you as anatomy and physiology students are quite famous already just because you're doing Bio 10,004. A lot of you might decide to get a ligation. You can get a venal ligation where they cut the part of the vein from here and here, and then they stitch it back together. It's purely cosmetic. Varicose veins might get a bit itchy at sometimes. That's about it. There's really nothing bad about it for your health complications. However, deep vein thrombosis is a different thing. This is essentially a blood clot. It occurs in your deep vein. One of the biggest issues about it is that it can not only will it cause some pain, swelling, and tenderness, if it actually gets dislodged while it's returning to the heart, that can cause blood clots at areas where you don't want it as well. This is one of the reasons why people who have blood clotting disorders, where their blood clots too easily, need to be permanently on blood thinner medications. And that's typically because if they get, and they need to avoid any high impact sport. A person that I used to play sport with, who actually broke his ankle, and then he realized that he had really bad leg pain. And afterwards, they realized that they did a test on him and worked out that he actually has a blood clotting disorder. And so, as a result, he can't do any high impact sport because he can't risk the chance of getting a hematoma because he's on blood thinners. So it basically means that if you get a cut or anything like that, it just won't stop bleeding. So it definitely is a bad thing in contrast to to varicose veins. Deep vein thrombosis is no joke. This is where your compression socks and all that stuff when you're catching a plane can actually help. This is also one of the reasons why, this is the exact reason why they recommend that you don't hit the booze too hard on a flight. You stay hydrated with water, and you get up and stretch every now and then. Does anyone stretch on the plane? Yeah, yeah, I definitely do. In fact, I went overseas in January. I'm off with my kids, and right, I was at the back of the plane and I'm stretching, I'm giving it heaps. And someone came up and said, "Why are you stretching so much?" And I went to give them a full lecture on deep vein thrombosis. And then I didn't realize, I thought they were just there to learn about anatomy and physiology. Works out they were waiting for the toilet. Because I was stretching at the back of the plane where the toilet's located, and eventually he just said to me, "Yeah, I don't care. I'm just waiting for the can." So there you go. And not everyone is interested in anatomy and physiology as we are, right? So things to remember: veins carry your deoxygenated blood. Back to that, so my always gets an aisle seat, easy to get up and stretch. Yeah, me too. Me too, Christina. I'm always big on the aisle seat. Everyone wants the window. I want the aisle. Okay. You got to remember these major points here as well. Again, there's not going to be a lot on the venous system in terms of massive sort of information in the exam, but there might be a small multiple choice questions in that first part of the exam. Now, don't study towards the exam. I know I keep saying that, but I'm just trying to give you guys some hints. Remember, you guys should be wanting to learn all of this stuff, right? It's all banging. It's all full send mode. That's what you got to be on, right? Send it. That's pretty much what you should be saying every time you open up one of these lectures. Do you guys say that to yourselves? Do you? I hope so. Are you guys waiting there on waiting for the recordings to come up? Fantastic moment. So the moment the lecture comes up, you're like, "Oh yeah, send it." All right, I'm pretty sure you do. Now let's talk about the heart. The heart is way cool, right? Now the heart is very complex too. It's basically relies on a level of constant conductivity that doesn't come from being innervated or hormonally controlled. And that's what you've got to remember. You have to know about the conductive system of the heart. You have to know the main structures of the heart and the main chambers, and the main morphological features. Those three main points are the ones that are going to get you. They're the money points for this lecture. You've got to know where it's located, and most importantly, as you can see, here's the sternum here, which would be there, which would be running down here. So you can see where it's located, nestled right in um, between your lungs. Yeah, there's here's a really good example here. Here's your aorta, right? Here's your ascending aorta, your aortic arc, and the descending aorta is going to run down like that. Look at where your main veins actually running up here as well. So your venous system and your arterial system run alongside each other. You can see that over here. Really good example. Okay. The pericardium surrounds the heart. You've got to know about the pericardium, and you've got to know the different layers of it as well, right? What ends up happening though is there's a pericardial cavity, and I'm just going to go move on so you can see this. And I'm going to come back to this, right? This is a pretty good one to remember, right? Here we basically have your pericardium, and this pericardial cavity here is nice. It's got some air and it's got some liquid in there as well. And what it does is it serves as a cushioning, serves as like a cushion for your heart. Your heart's in here and it's getting bumped around. Ever think about how rough and tumble you are, right? You probably, if you guys are probably off, I don't know, maybe you get up early and you go and do some jujitsu or something like that. you're getting thrown around and you're getting moved around, or getting bumped around playing, I don't know, footy or ice hockey or any of those sort of rough sports. If you're getting collided on, basically what ends up happening is, hang on a sec, I'm going to check that in a second. Your heart needs to be moving around and shaking around. Okay, hang on a second. I'm just going to look up this. Okay. I looked this up in all the diagrams, had the epo and had the endo and epicardium reversed. So the epicardium had fat, not the endo. So let me go back. So the fat is located, as you can see, around here. And what that does in terms of over here, right in between here, between your pericardium and the endocardium, is where you end up having that fat that's distributed throughout there. Does that help, Amelia? Yes, I think it's the gap in. But so no, it's not comprised of fat, but it's surrounded with some, and it provides that sort of level of cushioning. Okay, so I think it's more so. It should say more that it's supported by it as well. But no, you're exactly right. It's the gap in between where the fat is located. In between it's definitely not in the actual endocardium itself, but it's supported by fat and connective tissue that's around it as well. So, yeah, it's a good point. I'll actually change that for next semester. Thanks for the pointer there on the confusion, Amelia. But it's all good though. Yeah, fantastic. No, thanks for that. And again, if you guys notice any inconsistencies, as I mentioned to you guys before, I've been really trying my best to retool this unit. I think it hadn't been changed for a while when I came to Swinburne, so I've changed pretty much everything about it. And if there are any inconsistencies, let me know. I'd like to make this stuff better, even if it's in an ad hoc manner like that. Feedback is always good. Okay, here's the base of the heart, and located around here, and you can actually see everything that I mentioned before on that more simplistic diagram. You can see on here as well. You just need to know the main components of the actual morphological features of the heart. Should really be the size of an adult fist. If you want to think about that going into sort of like a softer balloon that will mold around the actual area, this would kind of resemble your pericardium and your heart. But you got to know you have to know that your pericardium is essentially the protective part of your outer sheath of your heart. It's not part of your heart, really. It's more a protective mechanism around it. Your four chambers are your right atrium, your right ventricle, your left atrium, your left ventricle. You should be able to sketch these out if you had to as well. Okay, the right chambers receive the deoxygenated blood, and the left chambers return the oxygenated blood back to the body to be pumped out to the body. You can see the flow here in regards to what's oxygenated and what's deoxygenated. The blue resembles deoxygenated or delivery from the veins, and then the oxygenated is the red stuff coming out through to the arteries. Now, this is a tough one, okay? You have to know the kind of conductive system of the heart. What ends up happening is that initially the components of the conductive system comes originally from the pacemaker cells, and they're located around in the SA node and the AV node. Now, basically what ends up happening is you end up having initiation of the contraction of the heart from the SA node all the way down to the AV, and that moves all the way down to your Purkinje fibers. There's 5 points that you've got to remember. First of all, the SA node here will initiate the actual the atrial activation. And this is all coupled with, remember everything we're talking about, polarization and depolarization. all that stuff there as well. Remember, this is an electrical conductivity, right? And it all comes from these particular components. It's coupled with depolarization and repolarization events as well, right? Remember, because it's a electrical conductivity of the heart. Stimulus is received here by the SA node. It basically moves down to the AV node as well. This continues down here, all the way down to the Purkinje fibers that you see there as well. So the impulse goes from here down to the AV node and all the way through. The initial contraction comes from the AV node, from the stimulation of your SA node to your AV node. That's the first contraction of the atrial contraction. Then, as it moves, the impulse moves down to the left and right bundle branches to the Purkinje fibers. That's basically when you end up having the atrial contraction completed and the ventricular constriction begins. So for those of you who are visual learners, you can see all of this here. These are some good slides to sort of commit to memory. Really not that hard. All of the text here is exactly what's on the other slides as well. But what's cool about this, for those of you who are interested in echocardiograms, you can actually see here the particular events that are occurring with each part of that cycle. And that leads us to an echocardiogram. I'm not going to ask you massive things about echocardiograms in the exam in terms of big questions or anything like that, but there might be some small questions in terms of the multiple choice stuff. So just know the basics. Know what regions of the actual contractive cycle are shown up on the echocardiogram. Spend a bit of time having a look at these. One of the most important things about the echocardiogram is what we can tell when you get an echocardiogram is what part of your heart might actually be defective. So if someone's got heart pain or they've got irregular heartbeat or something like that, it can be told by looking at an echocardiogram exactly what part of the actual heart is particularly has a defect. So this is a really powerful tool to being able to diagnose and understand irregular heart function. The arterial supply to the heart comes from the coronary arteries, the right and the left. These basically supply your SA and AV nodes and ventricles. They're really, really important, which is why coronary heart disease is such a bad thing. It's because it means your heart is not going to be receiving your blood. Remember, your cardiac tissue needs oxygen. It cannot rely on anaerobic respiration. So in that particular context, delivery of supply of blood to the heart is really, really important, not just so it can keep pumping good stuff out, but because it has no other option for respiration. That's why coronary heart disease, as we were saying, where you've got a blockage of one of the coronary arteries, is such a devastating disease. This is an atherosclerotic plaque. We'll talk more about atherosclerosis in other units, but it basically is it's an example of why positive feedback loops can be so bad as well. These are the things to remember. These are the main components that I want you to remember. The biggest part about this, which will require a little bit of memory work, is the understanding how conductivity from your SA node to your AV node, and then all the way down your bundles into the Purkinje fibers. There's also a part of the actual bundle that's called the bundle of His, and that was actually, I mentioned this in the lecture recording, but it's quite funny. The person who discovered that, I can't remember his full name, but he just abbreviated his name and stuck it into the nomenclature of the heart. The bundle of His is named after, if anyone wants to look it up, I can't remember the person's name, but the person who discovered the bundle of His just named it after themselves, the first three letters of their name. Imagine that. Imagine if I had found it, you'd all be saying, if I had discovered it, you'd all be saying, calling it the bundle of Greg. Imagine that, the bundle of Greg. Oh, geez, tell you what, that's got a good ring to it. On that note, that's all we've got time for. We have finished a little bit early, but this is it. You've got a week off. If your timetable, remember, have a look at the announcements, everyone. If your timetable shows that you actually have a lecture, a shoot tomorrow, and you've got one the week after, then that's because they can't break the actual on the electronic calendar system. They can't split 1 week into 2 weeks, so they're just doubled up. So if you've got a phantom time for tomorrow, then that's not correct. Okay, you go to the next one. All right, everyone. If there's no big questions, then we'll leave it at that. You're very welcome. Thanks, Daniel. It's definitely annoying. I think hopefully it'll clear up. All right, everyone. Have a fantastic Easter. Have a really good break, and you guys too. So, thank you all for attending this. It definitely makes it. It's very rewarding. I appreciate the attendance. All right, everyone. Take care. Have a great break, and I'll see you in the next one.
would absorb in this process.